Alcohols are organic compounds that contain a hydroxyl group, or OH, attached to a carbon atom. The general formula is ROH, where R represents an alkyl group. For example, methanol is CH3OH, ethanol is C2H5OH, and glycerol is C3H5OH3. This hydroxyl group is what makes alcohols unique compared to other organic compounds, giving them special chemical and physical properties such as polarity, hydrogen bonding, and reactivity.
So, how do hydrogen bonding in alcohol happen? We will be using ethanol as an example. The carbons are represented in gray, hydrogen in white, and oxygen are in red. Hydrogen bonding happens because ethanol is a polar molecule. If we look at the electrostatic surface, oxygen is more electronegative compared to the hydrogen atom. The hydrogen will be attracted to the more negatively charged oxygen. The hydrogen bond serves as a relatively strong intermolecular force that holds the alcohol molecules together. Hence, it will create a strong hydrogen bond between molecules.
One important property of alcohols is polarity. Because of the OH group, alcohols are polar molecules. This allows them to dissolve both polar substances, like salts to some extent, and non-polar substances, such as oils. Another key property is their boiling points. Alcohols have much higher boiling points than alkanes of similar molecular weight. For instance, ethanol boils at about 78 Celsius, while ethane boils at -89 Celsius. These differences is due to hydrogen bonding between alcohol molecules. Alcohols undergo two major types of reactions, oxidation and dehydration. In oxidation, primary alcohol first form aldehydes and can further oxidize to carboxylic acids. Secondary alcohols oxidize to ketones, while tertiary alcohols are resistant to oxidation. A common lab test uses potassium dichromate, which changes from orange to green when oxidation occurs. In dehydration, alcohols lose water when heated with concentrated sulfuric acid, producing alkenes. For example, ethanol can be dehydrated to ethene, which is an important raw material in the plastic industry.
Next, I will be explaining about the classification of alcohols. The alcohols are classified into three types. The first one we have is primary alcohol. Primary alcohol is an alcohol in which the hydroxyl group is attached to only one other carbon atom. It is usually found at the end of a carbon chain. One of the important characteristics of primary alcohol is that it can be easily oxidized. An example that we have here is ethanol. Ethanol undergoes partial oxidation to form ethanol, which is then further oxidized to form ethanoic acid. Primary alcohol has many practical functions in our daily life. It mostly serves alcoholic beverages, fuel, and solvents. Now, let's look at the reactions of primary alcohols. The most important reaction of primary alcohol is oxidation. During oxidation, the alcohol loses two hydrogen atoms, one from the hydroxyl group and the other one is from the carbon attached to it. In the first oxidation, an aldehyde is formed. Second step is where the aldehyde gets further oxidized and form a carboxylic acid. One way to identify that oxidation has occurred is by observing the color change. When acidified potassium dichromate is used, the solution changes from orange to green. Indicates that the oxidizing agent has successfully reacted with the alcohol. Next, I will explain secondary alcohol. A secondary alcohol is an alcohol in which the hydroxyl group is bonded to two other carbon atoms. The characteristic of secondary alcohol is that they can be oxidized to form ketones. However, unlike primary alcohol, they cannot be further oxidized into carboxylic acid under normal conditions. Secondary alcohol functions as rubbing alcohol, hand sanitizers, and surface disinfectants. The example that we have here is propan-2-ol, which gets oxidized to form propanol. The oxidation reaction in secondary alcohol only stops at ketone stage. This is because the carbon atom attached to the hydroxyl group has only one hydrogen atom available for oxidation. Once the ketone is formed, there is no additional hydrogen atom on the carbon for any further oxidation without breaking the carbon-carbon bond. The last one is tertiary alcohol. A tertiary alcohol is an alcohol in which the hydroxyl group is attached to a carbon atom bonded with 3 other carbons. Unlike primary and secondary alcohols, tertiary alcohols are highly resistant to oxidation. It is more chemically stable and does not undergo oxidation under normal laboratory conditions. Tertiary alcohol is mostly used in medicine, field additives, and as solvents in paints and coatings. So, why can't the tertiary alcohol undergo oxidation? This is due to the carbon atom that is attached to the hydroxyl has no hydrogen atom attached to it. For oxidation to occur, a hydrogen atom must be removed from the carbon bearing the hydroxyl group. Oxidation process is possible in primary and secondary alcohols because they have at least one hydrogen atom attached to the carbon. Hydrogen atom is essential for the oxidation process. The lack of hydrogen atom connecting to the OH group, making the oxidation reaction to not happen in tertiary alcohols.
Alcohols are significant in many areas. Scientifically, they are used as solvents and intermediates in chemical synthesis. In everyday life, alcohols are found in disinfectants, perfumes, medicines, cosmetics, and even beverages, like ethanol in alcoholic drinks. Industrially, alcohol serves as raw materials for plastic and detergents, as solvents in paint and coatings, and ethanol is widely used as a biofuel and fuel additive.
Now, I will discuss some important applications of alcohols in our daily life and industry. First one is glycerol. Glycerol is commonly used in cosmetics such as moisturizers and lotions due to its water-retaining properties. In pharmaceutical industries, glycerol acts as a stabilizer and often found in cough syrups. Isopropanol, also known as rubbing alcohol, it is widely used for cleaning electronic devices, disinfecting surface, and also as a solvent in cosmetics. As for ethanol, ethanol is most widely used in alcoholic beverages. In healthcare, ethanol is used as a disinfectant in hand sanitizers and medical wipes. Lastly, alcohol also have some general application. It is a versatile solvent used in laboratories and industries.
In conclusion, alcohols are an important class of organic compounds defined by the hydroxyl group. Their classification into primary, secondary, and tertiary explain differences and reactivity, especially in oxidation. With unique physical properties such as hydrogen bonding and solubility, alcohols play vital roles in laboratory chemistry, industry, and everyday life. From ethanol in sanitizers and fuels to glycerol in cosmetics, alcohols are central to both organic chemistry and our daily experiences.